Well, hey there, this is lessons 54 through 56. A lot to cover. If you hear some baby noises in the background, that's because there'll be baby noises in the background, but I think you will enjoy them as much as I do. It's kind of fun. Anyway, lessons 54 through 56. Lesson 54 is asking you to do something like this, where you have an equation, 2x plus 3y equals 24. And you have another equation, x equals 4y minus 10. And what they're asking you to do is they're saying solve for x and y. Okay, so let me explain what's going on here. If you remember an equation like this one, let's say x minus y, or x equals 4y minus 10. I'll take that second equation. What does that represent? That's what we would call a linear equation. All right, if I was going to draw it, it would be a line. So I'm gonna kind of do this. I'm not gonna be super accurate here, but if I wanted to draw this, I could say, okay, well, if x is 0, 4 times, if y was 0, 4 times 0 is 0, minus 10 is negative 10. That would be 1 point. 0 over 10 down. I'd make a dot there. And then if I were to pick another one, let's say y was 1. Well, what's 4 times 1? 4 times 1 is 4. Minus 10 is negative 6. So I go, in this case, when it's 1 over, it's negative 6 down. And I could do more of these, and I would end up with a line looking something like this. So this is a linear equation. This is also a linear equation. So if I were to say, make a little XY chart here, and using this equation here, I'm going to pick what if x was 0, or what's y? And I'm not going to go ahead and go through math, but you'd end up with another dot, another equation like that. Okay, another line. And so what it's asking for when it says solve for x and y is it's saying, look, there's only one spot where they cross. What is that spot? You get it? So if you have a linear equation and another linear equation, if you were to draw them, what you're asking for is what is that spot? In other words, in this case, it's 2 over 0. X is 2, y is 0. When they say solve for x and y, that's what they're saying. Where is the spot where they cross? That's what this is asking for. Okay, now drawing pictures of these things is nice and wonderful as long as they end up crossing at an exact clean spot. Well, what if they cross like in the halfway between numbers and your graph paper's not that great? We don't use this graphing method for everything. We can use other methods. When I say there are 10 methods, I'm not kidding. There are at least 10 that I know of to solve this. So one of them is graphing. We're not going to use that method, generally speaking, because it's not accurate, because it's determined by how accurate we can draw our things. However, if I had a super accurate computer drafting machine, I might use it that way, because that might be the easiest way to solve this. I'm going to teach you kind of what is often taught as the first method of solving these things. So we're going to take these two equations, and we're going to solve them using what we call the substitution method. So to use the substitution method in my equation here is what I'm going to do is I'm going to look at these two equations. I'm going to pick one where I know what one of the letters is. Notice I know x is equal to 4y minus 10. So I'm going to just simply take this and see where there's an x in this problem. Instead of using x, I'm going to use 4y minus 10. So that equation becomes 2 times, instead of x, 4y minus 10 plus 3y equals 24. And now I do this like we've been doing, well, all along. Distributive property, 2 times 4y is 8y, 2 times minus 10 is negative 20, plus 3y equals 24. I'm going to take all the y's, put them together. I have 11y, and I'm going to add 20 to both sides. and I get 44. So plus 20, plus 20, these will cancel. That's what I did. Okay, and then divide both sides by 11, and I get y equals 4. Okay, so by using the substitution method, I can simply substitute into here. Now, I still don't know the answer because I want to solve for x and y. Well, now I have y. Well, notice this equation. To find x, all I have to do is say, well, x is equal to 4 times y. Well, if I know y is 4 minus 10. Well, what's 16 minus 10? And that's going to be 6. So x is 6, y is 4. I have now solved for x and y. So if I were to draw those two things, the place where it crosses is 6 over 4 up, right here. So I'm going to have a line that goes like this and a line that goes like that. Somehow they're going to cross at that spot. And I don't even need to draw those lines. By doing it this way, I know where they cross. So that is called the substitution method. I would do that a couple more times. That was an explanation size. So to do it a little bit more carefully, we do another one. So let's say I have a problem like this one. Pick one from your practice problems. I've got negative x minus 2y equals 4, and I have y equals negative 3x plus 8. Okay, two equations. They both have x, y's on them. They are linear equations. I know it's a linear equation because there's an x and a y in it, and there's no x squareds or y squareds, and there's a number, so that tells me it's a linear equation. Okay, I can use substitution. I have choice. I can use this or this to do it. What I normally do is I look at what's easy. Well, this one's already got y equals that thing. Okay, so I'm just going to use it. Negative x equals negative 2, and instead of y, I'm going to put negative 3x plus 8. And then minus 2y, so negative x minus 2y equals 4. And so now I have negative x minus negative 2 times negative 3 is plus 6x. Negative 2 times positive 8 is minus 16 equals 4. So I'm going to combine the x's, and I end up with 5x. Add 16 to both sides equals 20. So again, plus 16, those go away. Plus 16, that's 20. And so divide both sides by 5, and I end up with x equals 4. Well, now that I know what the x is, I can use this one. Y equals negative 3 times 4, because that's what x is, plus 8. And that's negative 12 plus 8, which is negative 4. So if I were to draw that, it would cross at 4 over, 4 down, there. I don't know where those lines are. Who cares? But that, when we say solve for x and y, that's how you do it. Pick one, substitute, solve. And that's what your homework's going to be primarily on this lesson number 54. Okay, so lesson 55 is going to be some different stuff. Lesson 55 is talking about what we call complex fractions. I say they're complex because it means they're not simple in the sense that they're like a square is simple, a jiggity-jaggedy is complex. So in other words, obvious versus not so obvious, they're still thingies, but they're just seem more complex than they are. Okay, here's what I mean. What if you have a fraction over a fraction? 1/2 over 3/4. In your brain, you need to say that's 1/2 divided by 3/4, which is 1/2 times the reciprocal of 3/4. And then your answer is going to be 4/6, or reduce that to 2/3. Okay, so when you see a complex fraction, that's all a complex fraction is where you have a fraction on the top and a fraction on the bottom. what you have to do is basically 2 steps. First step, think of it as this divided by that. Second step, it's this times the reciprocal of that second one. And then you just do your math as normal. I could write this as 2 times 2, 2's cancel, and I would have automatically got 2/3 and not had to reduce it. And that's what I would normally do. Complex fractions work this way. And then what makes them awkward is something like this. Well, it's not a simple number. I don't know what to do. Okay, first thing, you're looking for that middle line. It's usually darker. So this is 1 over c divided by 1 over b. That's the first step. You just say that divided by that. Now, next step is I don't write it that way. I say 1 over c times b over 1. Remember, I just do the reciprocal of that second one. And then I multiply them together. 1 times b is b. 1 times c is c. Answer. So a complex fraction with letters can always be written as a simpler fraction if you do these 2 steps. So it doesn't matter how ugly it is, it still works. So I'm going to give you some increasingly uglier ones so you see how this always works anyway. So let's say I had a over x, big thick line, over b over a plus x. Okay, your brain needs to say it's this divided by that. Okay, so just write it. A over x divided by b over a plus x. Okay, next step, write this as a over x times a plus x over b. Now, what's a? Think of this as a parentheses, that'll help. So that's a times a plus x on the top and b times x on the bottom. That's the answer. I could, if I want to, distribute, and this becomes a squared plus ax. A times a is a squared, a times x is ax over bx. So this is the right answer, or this is the right answer. Kind of depends on what you're doing, on which one you want. But even if it's very complicated, it's still 2 steps. Write the top divided by the bottom, and then say the top times the reciprocal of the bottom, then just multiply. And you are done. Now I'll do one more that might look complicated, just so you can predict as I go, is it really that complicated? Let's do this one. X over m over d. Okay, so this one is like, wait a minute. Yes, this will help you. If you have a complex fraction, this is the big thick line. It's that divided by that. If you see just a single letter on either the top or the bottom, write it as that, and that will help you. So now this becomes x over m divided by d over 1, or x over m times 1 over d, so it's x over md. Answer. So x times 1 is x, m times d is md. So if you see something by itself, whether it's like a over b divided by c, well, this is, think of it as a over 1 divided by b over c. So if either the numerator or the denominator are solo, make it just over 1, and then use the same process. So that's lesson number 55. Okay, lesson number 56. Last lesson of the day. Lesson 56. Lesson 56 actually has a couple of parts. Let's start with the part that we've been doing. So for example, if I were to say graph 3x plus 2y equals 4. Remember when I said how to graph that? You just make an x and a y chart. When these numbers are in front of the letters x and y's, and it's not just x by itself or y by itself, it makes it harder to guess what number you should put. So that's what the purpose of this lesson is. So I'm going to give you a hint. I always pick 0. So if x is 0, then this becomes 2y equals 4. Well, 2 times 2 is 4. Easy enough. If y is 0, well, then it becomes 3x equals 4, or x equals 3/4. Okay, so that's not that hard. It's a little hard to graph when you're graphing 3/4 though. So there's a couple of tricks you can do for this. You can pick a letter that that will work and get rid of the fraction. Okay, and generally what you want to do is think of it this way. If I just rewrite this as 3x equals 4 minus 2y, and I divide both sides by 3, okay, then it becomes x equals 4/3 minus 2y over 3. Okay, and you go, okay, how's this going to work? Well, again, you can say, well, what if y is 0? And I'm going to end up with the answer. So it's not that complicated, but if you end up with a problem where you want to solve something, look for the number that makes this fraction go away. And it's always going to be one of these two numbers. It's either going to be a 2 or a 3. If I had another equation like 5y minus 6x equals 12 or something like that, I would pick, okay, let's try if x is 0 or if y is 0 and figure out what those are. Or I would say, okay, what if y is 6 or 5? See what those are. And eventually you'll see a pattern to this, and those will give you a little bit less fractions in your equations. But again, there's nothing wrong with that. That's the answer. You'd graph it. You'd say, okay, 0 over 2 up, make a dot, 3/4 over, 0 up, make a dot, and there's your line. Well, there's your line. Okay, so that's the easy part of this lesson, is just don't worry about the fractions. Again, just pick the zeros. That helps. There are other ways to graph these, which we will get to later. So that's why I'm not going to go into great detail on how to be a great grapher this way, because ultimately you'll end up doing it a different way in the long run. So at this point, pick zeros and ones and twos, or the numbers in front of those letters, to figure out the easiest way to go. Okay, next is this terminology thing. In math, these things show up. For example, let's say in our Living Liberty school, we have 100 kids. And Bob, Sally, Joe, Deanna, Serena, they all ride horses. Okay, and then, okay, but Sally and Joe are the only one who take karate. Okay, so what I'm doing is I'm saying, okay, we'll go, that's Serena, and S is for Sally. Okay, that's fine. What I can say, and what you're looking at here, is that the set of people who ride horses, horse riders, this means are members of the set. Well, it's Bob, Sally, Joe, and Serena. Okay, that's how you would write that. So if I'm saying who are all the people that belong to this group, that's how I write it. However, there's a couple other people. Mike, that's karate, so I might ask the question, is Mike a horse rider? Is he a member of the horse riders? And the answer is no. So we would say he's not a member. So Mike is not a member of the horse riders. This symbol here means is a member. This means is not a member. That's really all this is understanding what these symbols are. Okay, and if you have a list of things. Let's go with data points. For example, let's say I've got shoe sizes of everybody that's in the nursery. Well, somebody's got a 0, there's a 1, there's a 1, there's a 2, and a 3. And I say, okay, what are the shoe sizes? Shoe sizes. Well, those are going to be, or the shoe sizes are 0, 1, and 2, and 3. I don't have to list everybody's shoe size. I'm just saying those are that's the set of shoe sizes that we have. That's pretty much that piece. So lesson 56 is kind of twofold thing. One was going back and looking at drawing graphs. And then the second is understanding this terminology stuff. If you look on page 229, it's pretty obvious how it works. Just look through it, skim it if this doesn't make sense to you. And we will go from there. Have a great night.